Bogolyubov had said that Gell-Mann is closest to Einstein in intellectual capacity. I met Bogolyubov, says Stefan, in Belgrade, Serbia, Yugoslavia, in September 1978. Bogolyubov was the guest of the Serbian Academy of Sciences. At that time I was on the leave of absence from the Lebedev Institute of Physics of the Soviet, now Russian, Academy of Sciences, where I was doing research in theoretical plasma physics, in the plasma theory department led by Viktor Pavlovich Seelin. Bogolyubov and I had driven together in my car, along with Bogolyubov's wife and a collaborator, from Belgrade to Sofia, Bulgaria, where Bogolyubov was the guest of the Bulgarian Academy of Sciences. At that time, says Stefan, Bogolyubov was working on the quark theory. He talked about Murray Gell-Mann, who was one of the pioneers in the research. He also talked about Viktor Weisskopf, whom Bogolyubov had known personally, as the Massachusetts Institute of Technology leader, and as director of the European Organization for Nuclear Research, CERN. I had not known then that in a short 3 years I would have been at the MIT, doing research in tokamak thermonuclear fusion physics. Bogolyubov had said that Gell-Mann is closest to Einstein in intellectual capacity.
Our greatest 20th century theorist, Einstein, in 1905, when he published his paper on special relativity, had to break away from the accepted but unnecessary and wrong idea of absolute space and time, which was accepted by virtually everybody. And only then, when he broke away from it, could he take seriously as a general principle the symmetry group of Maxwell's equations for electromagnetism, which is proof of special relativity. He was then free to propose that that was the symmetry of all mechanics, rather than just the symmetry of electromagnetic equations. And of course, taken seriously was something that he did in two other cases in that same year, the same volume of the Annalen der Physik. When he was 25, in 1905, he published a suggestion of how to measure the density of molecules by observing small but visible objects that are struck by them, like Gauche particles in urea solution, or particles of ink in Brownian motion in water. And that way he was taking seriously the idea of a molecule as a real physical thing, the collisions with which could be directly observed by the human eye. In the same volume, he published the explanation of the photoelectric effect, in which he took seriously Planck's quantum as an actual physical thing that could have a collision. That it could have a reaction